Hello everyone, my name is Damian Wysocki. I work with Python over 8 years now, and today I will show you how Lambda development can be easy and fun. I work at MiroMe software as a solution architect. We really love the open source. Our expertise is e-commerce. And because we love open source, you will know about 2 tools that we built and that are open source. So let's start. First, I will start with this screenshot. I made a typo in the URL to just see this view. Are you familiar with this view? Someone? Okay. Yes, this is the Django. And what if I told you this is Django deployed on Lambda? If this sounds interesting for you, let's start. Get your Lambda on. Smyth and Lynara, Guide to Lazy Developer Live. One more thing before we start. You can see here 3 names. First one is Paweł Kucmus, which is creator of those tools. Second one is Damian Wysocki, and we together creating benchmarks for those 2 tools. We testing those, giving the feedback. So from this place, I would like to really thank you guys. So let's start. To give you a little bit context in this presentation, I will talk about Lambda that are exposed over HTTP, because our case was to have Lambda over the HTTP. But then we have first dilemma. Locally debugging that kind of Lambda can be painful. It's the workflow is not efficient, I would say like that. So first we write the code, deploy it on AWS, wait some time, check the logs, and if we found any bug, we we again write the code, deploy it, etc., etc. So it's slow feedback, as it's really hard to debug. But there is still hope. With the PyTest, we can test it easily, but there is the catch. PyTest doesn't test your Lambda code over the HTTP, so you don't have the full, let's call it integration test, right? Whenever you deploy it on AWS, there still can be some integration bugs. Serverless, it's really powerful framework, but for example, it doesn't support the latest version of Python. It exposes Lambda over HTTP, but if some of you working with the Lambda and thought that why I cannot just use my debugger, I feel your pain, because with serverless we cannot use our debugger. What about local stack? It's really great for mimic AWS locally. It supports most of the features, but as the same as AWS, deploy on local stack or the code refresh, it took some time, 1 or 2 minutes, just like on AWS. And let's be honest, developers are a little bit lazy, but that doesn't mean that we don't care about the efficiency. All I want, and maybe you also, is that I want my server, my application to be refreshed whenever I save the file. It's like we are used to it, right? So let me introduce the first hero, Smyth. This is the screenshot from the documentation of the Smyth. And Smyth simulates AWS Lambda locally. I would like to show you how setup looks like. So we have configuration on our TOM file. We need to set the most important thing here is line number 6, where we define the path to our handler. On the right side, we have our handler. It takes 2 arguments like the Lambda event and the context. And with the one command, we are ready to go. So yeah, this is the most important part. Line number 6, where we define the path and the name of our handler, right? Okay, so whenever we run the Smyth that is configured like we saw in the previous slide, we can see that is up and running. But what will happen when I just make any changes and save the file? It will recognize that we make the change and start restarting process. Yeah. So it shut down the processes with our handler and started again. Like it's no more waiting. You make the change and it's already there. What about cold start? Yes, we can simulate it too. The Lambda handler is imported just once on the first request, like just on AWS. Concurrency, also it's not the problem. We need to add the configuration to the TOM file, and we can see on the bottom that Smyth spawned 2 processes of our handler. So in this big picture where the Smyth is. So whenever the requests come to AWS through the, for example, API gateway, under the hood that I don't know how, maybe you know how AWS works under the hood, but at the end we have event. And this event can be understood by Lambda. So with the Smyth, we take this AWS thing, put it out, and put it Smyth into this place. So request comes from Uvicorn, then Starlette, then Smyth execute this request and translate it into the same event like the Lambda will receive on the AWS if it will be deployed on AWS. What about one Lambda invoking another, if this is your case? Also, it's possible with Smyth. We need to add to our TOM configuration the second handler, like we add the first one. On the line 5, we need to add the endpoint for our Smyth, and we again are ready to go with a little bit more complex Lambda. What about event generation? Examples and default event generator in Smyth is AP Gateway v2. But what if you want to use on AWS, for example, API Gateway v1? It's possible. We can create our own event generator. It's a little bit complex, but this is how looks this. Oh, it's not. Okay, sorry, you will not see the rest of the code, but believe me, there is a body that we convert the event, the request, and convert it into the event v1. This example is also in the documentation of Smyth. And what we need to do in the configuration, we need to add path to this event generation function. And we can create every event that we want. There is more. With Smyth, we have different dispatch strategies. also environment variable injection, custom entry point for custom use cases, and even non-HTTP invocation. Everything is on documentation. The link to the documentation will be also on last slides, and I will post also these slides on Discord. So this is the Smyth. Now we know how locally really nice debug and work with the Lambda over the HTTP, but there is another problem. Now we think, okay, we can debug and work with Lambdas really easy and fun, but now we need to sell this whole serverless thing to our team, and you're saying to them, oh, it's really nice, it will be fast, it's scalable, and then one guy from the back saying, but I would like to have Lambda, but I still want to write in FastAPI, for example, just because. It's not a problem. Oh, yeah. It's not the problem. So let's meet second hero, Lynara. This is also a screenshot from the documentation. So Lynara allow you to have FastAPI or any other ASGI framework on the Lambda. So let's see where in this I have, okay. Sorry, I have a delay. Yeah. So where is the Lambda? So now we know that whenever request, now we know that on AWS, when, Lambda works with the events. Whenever request comes, somehow in magic way, AWS converts it into the event, and that our handler needs to process. But FastAPI or any other, or Django or any other ASGI application don't understand events. They understand ASGI requests, right? So this is what Lynara does. Takes the event and convert it into ASGI so every other framework can understand it. This is how looks set up. Yeah. On the line 5, we have just initialization of FastAPI, like we always do. Then on line number 6, we wrap our application over the Lynara, and then after the line 8 and after, we have our Lambda handler that takes as first argument event, and then we're running the Lynara. What about lifespan support? We can choose, not all ASGI framework have lifespan, so we can choose whenever we want turn off, turn on, or make it auto. So no matter what it is, if it's Django or FastAPI, it works like we expect even on AWS. Interfaces support. We can support different interfaces. So whenever we want our FastAPI to understand AP Gateway V1 or V2, it's possible. Those two interfaces are in Lynara by default. You can use them. But what if you want to have custom interface? Maybe you want to have, maybe you want to process DynamoDB events or SQS. It's possible. You can build your own interfaces because it's open source. You can do whenever you want. Also, everything is described in the documentation. Links, of course, will be at the end of the slides. We are developers. We like the numbers. We like benchmark. So let's see some numbers. I have few setups here. Lynara with Django, Lynara with FastAPI, with the Starlette, and also I have pure async Lambda and pure Lambda. As we can see, everything here works quite good, right? The numbers are really, really high. That was not the complex test, it just needs to return the JSON. We can see that even Django doing quite well. It can handle 2.5K of requests per second, which I think this is really good number. Of course, FastAPI and pure Lambda is a little bit faster. It's almost 3K requests per second, but still, I think all of those setups doing really, really well. But one thing to pay attention is this red line. It's telling us how many execution of Lambda each of setups use. So as we can see, Django, to catch up with the others, use everything what we gave to use. Because if I remember correctly, the default Lambda limit is 800 or 700. You can ask AWS for more, but by default, there is 700 or 800. So Django, to give us these results, use all resources that we gave. We can think about it, and the others, FastAPI, maybe async Lambda, the performance is over the same. So you can use your FastAPI on Lambda with the performance of clean Lambda. As a bonus, I would like to talk about cold start performance. If we have just that simple Lambda, the cold start will take half of the second, right? We have two states of the Lambda, the cold one that is hit the first time, so it needs to initialize everything, and the warm when it's ready to go. So what if we just import FastAPI and deploy this code on AWS? Let's see how the cold start will look like. We have over 1 second. So we have 1 second, we need to wait 1 second more just because we import the FastAPI. And this is how cold start looks like. Whenever we hit our endpoint with the Lambda, it needs to import every dependencies. This is why we need to wait so long. But with the Lambda layers, we can fix this issue. Just in short terms, Lambda layers is for moving your all dependencies to the layer and separate it from the code base. So by doing it, just to moving dependencies to the layer, we reduce cold start by 1 second. So we goes back to the first results that the cold start is just the half of the second, just with moving dependencies to the layer. And this is some, for me, maybe for you also, interesting screen. This is how looks the dashboard of the Lambda, and this one doesn't have layers. First thing that we can notice that we don't see code preview. Not big deal. But the package size is 26 megabytes. And what if we will introduce the layers to the same Lambda? First, without changing the code, without changing our code base, just with moving dependencies to layers, now we can see our code. We can see that we import Lynara, we import FastAPI, and all of our code is visible. And nice thing now, without changing anything in the code, now I have better, package size is 5 kilobytes. From the 26 megabytes, we reduce the Lambda to 5 kilobytes. So use the layers whenever you can. And second bonus, I don't know, I think I like bonuses. I will talk about case. Probably you will never face this one, but I would like to show the possibilities. So here I have AWS calculator where I comparing EC2 with the Lambda to see the cost. The configuration you can see here of the Lambda and here of the EC2. So on the beginning, it's really cheap, right? But there is some number. In our case, is 100 million requests per month to cross the line where Lambda stop being cheap. In this configuration, I said that average response time is 100 milliseconds. But let's change it to 1 second, right? 1000 milliseconds. So now we can see that we cross the line really early, right? Faster than in the previous example because of the response time, because of how much Lambda will compute each request. So, and before I go further, this calculator is made by great guy, if I remember correctly, Marcin. Just check this website and you can play with this calculator. I will put this link also on the disk. So, what is our case? We have our Lambda written in Python, and we cross this line, and there is the question, why is so expensive? So you gather your team and think what you can do. Idea is to move to EC2. So let's do this. But with the pure Python, it's not that quite simple. You need to rewrite your code to the FastAPI and then deploy it, right? And now this is this expensive, right? It takes time, so it is expensive, right? So with the Lynara, the same case, we have Lambda. Now it's on FastAPI using the Lynara. We cross this line when Lambda stopped being cheap. So we gather the team, make the decision to move to EC2, and basically that's all. We can deploy our Lambda on EC2. Of course, I know that from the technical perspective is one-to-one, but I know that we don't write the Lambdas in the same way like we will write the real service, right? Because by definition, Lambda should be small, should do one thing. So from the developer perspective, it's maybe not one-to-one, but from the technical perspective, is possible. So whenever I think about, just for summary, basically it's your choice what you would like to achieve. Maybe you want developer and staging environment on the Lambda because of the cost or maybe some other issues, but the production on EC2, right? The same code base, but on different services on AWS. Maybe you have new project, you're starting new business, and because of the cost or any other reason, you can have your early stage of development on Lambda, mainly, I think, because of the cost. And what about creating CI/CD for the QAs that can, with the one button, create their own private environment? Yeah, it's also possible. And maybe you don't want to use AWS. You have FastAPI, so it can be hosted, deployed everywhere. So maybe you want to move from Lambdas to, I don't know, your private machine. That's all. Thank you. On this QR code, there will be link for the Lynara and Smyth repositories and some other cool stuff. Thanks.